So I'm Dylan.
Hi, I'm Loren, fourth year electrical engineer.
We implemented an analog communications protocol. We thought it would be sort of a cool extension of like I2C, SPI, UART to do our own, specify it, and instead of having ones and zeros being transmitted on digital line, we can tie in the ADC and the DAC and actually just transmit analog values instead.
So, we give you ARCOM.
Or arbitrary waveform generator communications.
Yep.
What do you-
Bam! Yeah. So, as Dylan already mentioned, the purpose was to provide another communication protocol similar to ones we've studied in class. It's based on like pseudo-analog signals. You know, it's not just binary, but it's not really true analog.
They're discretized.
Yeah, there's only a couple of different values you can get. And then it was just a purpose just to do, device-to-device communications using arbitrary waveforms. Here's a timing diagram of data transfer. On one of the devices, there's an assert pin that comes out of one of the outputs, and the device just drives it high, and then the data is sent, and then the other device picks it up, and then here's the other device sets it to assert pin high, and then sends its data along the bus.
So we theoretically have full duplex communications.
This is the black box diagram for the circuit. So here's the, my controller, here's his controller. We use the onboard analog to digital converters on both. And then the external digital analog converters. And that was an SPI device. And then we have the outputs of the DACs going into the ADCs on the other device. We had a couple red, green, blue LEDs attached that were just basically the transmit receive indicator. And then due to constraints on different grounding levels and voltage references, we have the VCC from one of the devices attached to both of the DACs, and then a common ground between both of them as well.
And both analog and ADC references. They share the same reference voltage. Cool. We chose a specific character set to do. We couldn't do all the ASCII characters, so we just chose a subset of that, and we'll get into why later. But it's everything that you need to make legible text, write email addresses, do hashtags and all that. Right now we can transmit at 235 baud. That's mostly limited by software delays that are put in the code, but we sort of figured theoretically we could get up to 3.8 kilobaud, which is just I guess in this language it means that's just characters per second. But this is plenty fast for just chat, which is the application that we're doing.
So pretty much can't type faster than that.
So because we're using analog and the ADC, it's not, both the DAC and the ADC aren't perfect. We had to, I call this a fuzzy analog value searching. And this is why we had to choose a reduced character set. I can't just transmit 100 and I'll get 100 on the output. So instead, I chose a range of values to represent. Right now it's 106 to 110 that represents V. And that just goes through, this is just a small section of our alphabet. We have, I think, 48 characters. And so if we want to send a V, we're going to send the center. We're not going to send either edge because that would be kind of risky. We're going to send 108. And to do that, we have just a bunch of lookup tables. It's all fast, but it's all hard-coded, not super flexible at this point. But theoretically, we can come up with an algorithm that can do it on the fly as well. But the lookup table is about the best we can get. And we got a video showing you how these characters are mapped to analog values and what that looks like in the time domain. So all these are just different characters, and the ADC, these are sent out by the DAC, and the ADC is just sampling them and translating them with that fuzzy algorithm into back to the digital world. And so we have a demo also, a live demo. Can we have a volunteer? Does Anybody want to type text? Yeah. It's on this computer.
Yeah.
So if it works, you're gonna see what you send on there, and it's all going through in analog world. We could check out the script, but we can't. Also all uppercase. That's part of the character set.
Oh, yeah.
Oh.
That's coming off my computer onto the screen.
Type something to him.
Oh, that's what happens if you do a non-legal character.
Well, but yeah, backspace is not legit. It's not part of the character set, and it's sort of not really a character. All right, that's our demo.
And there's also, we have the little transmit receive LEDs. If you want to come up and see
they're
that,
pretty cool.
then you can.
Here,
Just
do some so you can get in the video.
You can see like
And
his
then the
his
colors,
green when I transmit.
red is transmit, green is receive.
And then it just switches back and forth.